So this is going to be our first EOC review video, and we're going to talk about domain and range. And I've got several different situations here, how we can use domain and range to describe those situations. First up, we're going to look at domain. Domain is from left to right on a graph, and we always want to start from the left to the right. We're talking about the x values. We want to go the smallest x value to the largest x value. Okay, so the x's are in general the input of the function, and they are called the independent variable. Okay, then we have the range of a function. Range is going to be from the bottom of the graph to the top of the graph. And again, this is talking about y values, so we want to do the smallest y values to the largest y values. Okay, the y's or the range are the outputs of the function, and they're also known as the dependent variable. So a lot of times I like to use the word dependent in a sentence and rearrange the two things that we're talking about to see what would make sense. What depends on what, okay? So first up, we have this situation where Sam surveyed students at his school. He asked students how long they studied for the last test and the score they received on the test. Okay, so we want to determine which represents the domain, which represents the range in this situation. So like I said, I like to throw that word dependent in there to see what makes sense. We're comparing two things, how long they studied and the score that they received on the test. So if I read it this way, the amount of time that they studied depended on the score that they received. That doesn't make sense. But if I flip it around and say that the score that they received on their test depends on how long they studied, that makes sense to me. So then I know since the score they received depended on something else, then the score is the dependent value or the range. And that makes how long they studied the domain. So the domain is how long they studied, and the range would be the score that they received. Okay, next up we're going to look at these ovals. This is called a mapping. So you're going to have an assortment of numbers in the first oval that always represents the input or the x values, and then another assortment of values in the second oval that represents the output or the y values. And they're going to draw arrows connecting different numbers together that would represent an ordered pair. So for example, -1 connects to 5, so that would be the ordered pair -1, 5. And so forth. We're just looking at the domain and range. And since input represents domain and output represents range, then I can list my values in braces. So I'm going to write that the domain is -1, 0, 1, 2, 3, and the range is 3, 5, 11, 21. And notice when I listed those numbers in the braces, I listed them from least to greatest. Okay, the next situation is the table here in the middle that has time and distance. So they didn't really give us much. We don't know if it's seconds or miles. We didn't get that. But if I think about it, usually distance depends on time. Distance depends on the time that you drive your car, for example. So I'm going to list out the domain as the time. So that would be the values 0, 3, 6, 9, and 12. And then the range would be the distance. So I would list out 0, 1, 2, 3, 4. So again, I listed my numbers from least to greatest in the braces. Okay, now we're going to look at this situation where Cohen is selling magazines. He receives $20 to start selling magazines and $1.50 per magazine subscription he sells. So if you think about it, it would make sense that the money that Cohen makes is dependent on how many magazines he sells. Doesn't make sense the other way around. How many magazines he sells doesn't depend on the money that he makes. Okay, so I'm going to write an equation that would represent this situation. So I can say y equals 20 plus 1.5x. Okay, since he starts out with $20 and then we're adding $1.50 for each magazine he sells. All right, so that would mean that the domain is our x, and that represents the number of magazines. The range is our y, which is the money that he earned. Okay, last we have this picture down at the bottom, just a graph of some type of a function. And notice there's an open circle on the left-hand side and there's a filled-in circle on the right-hand side. Remember that an open circle would be not equal to and a filled-in circle is equal to. So that's going to be important when we talk about the domain and range. So I'm going to start with the domain. And like we said at the very beginning, we're going to start left to right. So I look at the x-axis from the left to the right and I see what values does this function use. So I draw some little lines going from the left to the right, and this goes as far left as -3 and as far right as +1. And then notice when I wrote this down, I used a parenthesis with the -3, but a bracket with the 1. So since that was an open circle on the left-hand side with the -3, then I use a parenthesis. Parentheses are used for not equal to or infinity, if our graph kept going to the left side forever. But on the right-hand side, since it did equal 1, then I use a bracket to show that it's equal to. Another way that we could write this is in interval notation, or this is interval notation. We're using inequalities next. So I could write it from -3 less than x less than or equal to 1. So this means that my x's are between -3 and 1, and there's only equal to 1. Okay, it won't equal to -3. Okay, so then when I look at the range, we're talking about the bottom of the graph to the top of the graph. So I want to see how low are the y values, how high are the y values. So for the range, they go from -4 to 0. Okay, and since at -4 that is a filled-in circle, then I can use a bracket. And at the very top 0, there's a point there at the top of that curve that would be equal to as well. Even though we've got that -3, 0 point on the left-hand side that's an open circle, in general, there is a y value of y on this, of 0 on this function. So then I could write it in inequality notation saying -4 is less than or equal to y, less than or equal to 0. So I've just talked about domain and range in a variety of different ways. As we go through the review, we may bring it up again when we're looking at different types of functions. But this is just a good start to talk about domain and range and how they're related in different situations. Remember, domain is from left to right on the graph. It's the x values, it's the input of a function, and the independent variable. The range is the bottom of the graph to the top of the graph. It's the y values, the output of the function, and the dependent variable.